Hi everyone, today I'm going to solve the very latest Add Maths O-Level Paper 2 from October-November 2023. So let's begin. The first question, we have to find the point of intersection. First of all, we need to find the gradient of the first line, change in y over change in x. Gradient is -half. So if I put it into y equal to mx plus c. Now I need to find c. So let's take one of the points. Let's take this point on the line. So C will be 23 plus 2, 25. So this line, the equation is y equal to -half x plus 25. And the other equation is y equal to 2x plus 5. Now we can solve these two system of equations to find the point of intersection either by substitution or the elimination method. I'm going to go for the substitution method. So I'm going to substitute the value of y So I'm putting the y's equal to each other. So let's solve this. X is 8 and the y value will be 2 times 8, 16, plus 5, 21. So 8, 21 is the coordinates of P. Moving on, find the distance of P from the origin. Well, we can use the distance formula. Between the point P and the origin. So it will come down to something like 22.47. So that was answer to question 1. Now we have the next question here, question 2. All right, so we have a line, and this is the tangent to the curve with this equation. So where these two lines meet, we will have a specific point. So let us try and find where the point of intersection is between this tangent and the line. So that is going to be where the two lines meet and the two x and y values are going to be the same at that point. So we can equate the two y values. So this is going to be x squared plus 2kx. And if we bring everything together, so we are going to get now for this equation, this is a quadratic equation, and for this to have a solution, the discriminant of this must be greater than or equal to 0. And so b squared minus 4ac must be greater than or equal to 0. So here our b is that, a is 1, and c is that. So let's form this equation here. So we're going to have b squared minus 4ac So this will end up like this: 4k squared plus 4k plus 4 minus 24k minus 4. Oops, I think I've made a mistake. $8k. And so 8k take away 24k is 16k. All right, and then so since k is a non-zero value, k must be equal to 4. Now here's the next question, and we need to find the height. Now the volume has been given. And the volume is pi r squared h. So in order to find the height, we have to divide the volume. Well, the pi's cancels out. And if we expand that, we get so now we need to simplify this further. So let us multiply both the numerator and the denominator with this minus 7. So what happens is 64 Well, actually, I need more space, so I need to come down here and continue. And the bottom square difference of the two squares, so that'll be 48 minus 49. Well, so this can be written as 4 minus root 3. Now moving on to number 4, we have to solve this equation. So first step, and then we can subtract the powers. So 2x take away half x is 1.5x. And that equals 10. So now if we take ln, so 1.5x is equal to ln 10. And that will eventually give you, well, 0.2017. Now this expression, so if you remember the rules for log, when there's a difference, it becomes a division. So first of all, let's take y squared, and then we divide and that equals to half, and then well, if you consider this to be times 1, and in terms of log, 1 can be written as log 9 base 9. So when you have the same number and the base, that equals to 1. So let's write it like that first. And then we can take the power, take half on top of 9, so that's going to be 9 to the power half. Square root of 9 is 3. So we can get rid of the logs and say that that is equal to 3. And then this will turn into a quadratic equation. And then if we try to solve this, so 9 and 3 are factors of 27. So if we factorize this expression, this is what we'll get. And so these are the values of y3 and 9. Next question. So first of all, let's find dy dx. Okay, so at the point where x is equal to 1, the gradient dy dx so the gradient is 1. So this is the gradient of the tangent. Now the gradient of the normal, which is perpendicular to the tangent, will be -1. So now let's find the equation of the tangent. Y equal to -1x plus c. And if we plug in the values of 1, 1, so our c is 2. So the equation of the normal is y equal to -x plus 2. Right, next. Now where the normal and the curve meet, this is the equation of the curve, and the equation of the normal is y equal to minus x. Now at the point of intersection of these two, we are going to have the y values, we can equate the y values. Well, so let's do that. So this will be equal to 2 minus x at the point of intersection. And now let's put everything together. So that will be 13x minus 7 equal to 0. Now we already know that the one point of intersection is 1, 1. So now if we need to factorize this cubic expression, we would have to do long division, because x minus 1 is going to be a factor, and then we are going to get a quadratic equation here after the long division. So let's start long division. I'll just do it here on the side. Starting off with x squared and then negative 6x plus 7. So now we have this. Now this, in order to solve this quadratic equation, we would have to use the formula of x equal to minus b is negative 6 plus minus square root of 36 minus 4ac over 2a. Sorry, it's not a square here. Well, so it's going to end up as 6 plus minus square root of 8. And square root of 8 is 2 root 2. And so this is going to be 3 plus minus square root of 2. Question 6 is an integration. So the first thing we can do is expand the numerator. and then separate. So if we divide each of these terms by x, we'll get x plus 4 plus 4 over x. So now we can integrate each of these terms separately. Integration of 4 by x is 4 ln x. And if we put the limits, so remember to put these brackets, otherwise you might get into trouble because you have a negative here. Well, so this is 4.5 plus 12 plus 4 ln E3, and then negative 10 negative 4 ln 2. So this will end up as 6.5 plus 4 ln 3 over 2. Number 7, the velocity will be at ds dt. We have to differentiate the above expression for displacement, so that will be -1, and acceleration will be dv dt. So if we differentiate the velocity equation, we get this. Okay, next, well, when the particle is at rest, that means velocity is 0. So we put the velocity equation equal to 0. Right. Well, if we substitute, let's say if we put x equal to e to the power negative 2t, then what happens is no, actually, let's try something else. So let's try this. Now if we multiply throughout by e to the power 2t, then what we are going to get square So this looks like a quadratic equation. And now if we can use substitution, let's put x equal to e to the power 2t, then this becomes 3x squared minus x minus 4 equals to 0. And let's try and factorize this. So the factors are 3x minus 4 and x plus 1. So if we now go back to our e, then we'll get some solutions. So this equals 0 or (4/3). This is not possible, and the only solution we're going to get is from here. So that will be t one half of ln 4/3. Next, we need to find the acceleration at this time t, which is at this time. Well, our acceleration equation was 6e to the power 2t plus 8 negative 2t. So if we substitute the value of t into this, then what we get is 6 and if you use your calculator, then well, this will actually be 6 times 4/3 plus 8 divided by 4/3. So that's going to be 8 plus 6, 14. Find dy dx, so we have to use the product rule. X two x cos 2x plus sine 2x so this will be 2x cos 2x plus sine 2x. Equation of the tangent at x equal to pi by 4. Now if we put x equal to pi by 4 in the equation of the curve, substitute x by pi by 4, we'll get the y coordinate of this point. So sine pi by 2 is 1. So the y coordinate is pi by 4. So the point where we are trying to find the tangent is pi by 4, pi by 4. Now what's the gradient? What is dy dx at this point? So we substitute pi by 4 into the dy dx equation. Well, so this is coming down to 1 because cos pi by 2 is 0 and sine pi by 2 is 1. So now the equation of the tangent is y equal to 1x plus c. And if we substitute these values into this equation, so we're going to get c equal to 0. So the equation of the tangent will be y equal to mx plus 0 or y equal to x. So our answer to part A was this: dy dx was equal to 2x cos 2x plus sine 2x. Now if we integrate both sides, then what happens? We get y, and we'll get our okay, wait, first let's write this. And if we integrate sine 2x, we get 1/2 cos 2x. So the integration of 2x cos 2x will be y minus 1/2 cos 2x. Sorry, because this was negative 1/2 cos 2x. So this will eventually become y plus 1/2 cos 2x. And our y was x sine 2x. That's the original equation of y. And of course, let's not forget we have some limits here, 0 to pi over 6. So now pi over 6 sine pi over 3 plus 1/2 cos pi over 3. Remember to put the brackets. Well, if you plug in 0, that will become 0 plus 1/2 cos 0. So sine pi over 3 sine 60 is root 3 over 2. So this will eventually be pi times root 3 over 12. And then cos 60 is 1/2. So that's 1/4. And cos 0 is 1. So finally, 1/4 take away 1/2 is 1/4. That should be the answer. So here we have an arithmetic progression that has 12 terms. The first 3 terms, their sum is negative 36. Well, the first 3 terms will be first 3 terms are going to be a plus d, and a plus 2d. So if we add them, the first 3 terms, we're going to get 3a plus 3d, and that equals to negative 36. And now let's think about what the last 3 terms are going to be. So the last term will be the 12th term. The 12th term is going to be a plus 11d. The 11th term is going to be a plus 10d. And the 10th term is going to be a plus 9d. Now the sum of these three last terms is 72. So if we add them up, 3a plus 11 plus 10 plus 9 is 30d, and that should be 72. So now we have these two simultaneous equations to solve. So if we simplify this, this is going to be a plus 10d divided by 24. That is when we divide by 3 on both sides. And here, if we divide by 3 on both sides, we get a plus d is negative 12. So a is negative 12 minus d, and if we substitute that in here, negative 12 minus d plus 10d equals to 24. Well, this is going to be 9d is 12 plus 24. So d will be 36 divided by 9. So d is 4. And if we plug that in here, a will be negative 12 minus 4, and that is negative 16. So the first term is negative 16, and the common difference d is 4. So here we have a geometric progression where the first term is 1 and the common ratio is 1.2 divided by 1, which is 1.2. And we need to find the sum that is greater than 500. Okay, so the formula for sum is that and so this is going to be 1, 1.2 to the power n minus 1, 1.2 minus 1, and this has to be greater than 500. So this will be 1.2 minus 1 greater than 500 times 0.2. So this will be 1.2 to the power n minus 1 greater than 100. And so 1.2 to the power n is greater than 101. So if we take log on both sides, so n is going to be log 101 log 1.2. So n, if you do that, you get 25.3. So the question says we need to find the smallest value of n. So if n has to be greater than 25.3, n must be 26, like the smallest that n can be is 26. So now let's try number 10. Cot x is cos over sine and tan is sine over cos. Now if we take like change this to negative, then what happens is we can write the denominator as sine x minus cos x. Basically, we're factoring -1 out so that we have the same denominator, and then we can combine the two together. Now sine squared minus cos squared, this is a difference between two squares. So it's like a squared minus b squared. So that can be factored as sine x plus cos x times sine x minus cos x. And so sine x minus cos x divided by sine x minus cos x is 1, and so we are left with sine x plus cos x, and that was what we were asked to show. Now let's move on to 9b. So again, if we write cot x as cos over sine, and then cosec is 1 over sine, and tan can be written as sine over cos. And so what we can do is multiply both sides by sine x cos x. So that will become 9 cos square x plus 3 cos x and on the right side we're going to have sine square x, and we can write sine square x as 1 minus cos square. So we could do it something like this. Put the squares down here. And then if we bring everything together, this is going to be 10 cos square x plus 3 cos x negative 1 equal to 0. So that's a square actually. Let me write it nicely. Now this is a quadratic equation and it can be factorized. So we could say 10 cos square x plus 5 cos x minus 2 cos x minus 1 equal to 0. And then take the common factors out. So that will end up as 5 cos x minus 1 and 2 cos x plus 1 equal to 0. And then so cos x is going to be 1/5 or negative half. And now we need to find all the values of x between 0 to 360 degrees. That is true for this. So if we take cos inverse of 1/5, so that is 78.46. And cos is positive in the first and fourth quadrant. So in the fourth quadrant, that is going to be 360 take away 78.46, which is 281.54. So these are the two values for cos x equal to 1/5 and for cos x equal to negative 1/2. So if we take cos inverse of negative half, we get negative 60. So cos is negative in the second quadrant. So that would mean 180 take away 60, and that gives us 120 degrees. And in the third quadrant, it's going to be 180 plus 60, and that would give us 240 degrees. So the four values of x, the final answer is 78.46, 281.54, 120, and 240 degrees.